All right, so you guys had time to think. Still only 3 questions. Okay, to put this into polar form, first thing you do is draw the picture. The only difference is instead of the x and the y-axis, you have the real and the imaginary axis. So basically, you're just plotting the point 3, negative 4. That's all it is. So you go 3 on the real, 4 on the imaginary. So you plot the point 3, negative 4, and then you draw a vector that goes from the origin to that point. That's what a complex number is. It's a vector. So this is just like the quiz. You draw a triangle. If this is 3 and this is 4, how far from origin are you?
5.
5. See, so to change this to polar form, remember, it's r, kiss, theta. R is how far you are from the origin, so that's just 5. Okay, now, what is this angle right there? Now, you can take out your calculator, but does it say use your calculator? Yeah, because they want it in degrees, right? So, how do you figure out this angle here? Let's call this angle theta. You can go tangent theta is equal to opposite over adjacent, or you can go cosine theta is adjacent over hypotenuse, or you can go sine theta is equal to opposite over hypotenuse. It doesn't matter. Why don't we just stick with tangent? So how do I figure out this angle? How do you figure out the angle in your calculator? Tan inverse 4/3. So, if you punch this in on your calculator, let me think. Don't tell me. 53.1 degrees. Yeah, I still got it.
I didn't know that's correct.
I just know. I don't know 3 decimal places though. Why don't we just go with 53.1 degrees? So, if this angle is 53.1 degrees, what's the angle going all the way around like that?
360
Wouldn't it be,
minus.
yeah, 360 minus that? So, what is 360 minus 53.1? You gotta borrow, so this can become 59, so it can be 306.9 degrees. You know, in calculus, we don't use a calculator. In calculus, you know what we do? We just go 2 pi minus tan inverse 4 over 3. Or 360 minus tan inverse 4. We don't need to use the calculator. But that's what your book wanted you to do. Okay, 23. Now anyway, on my test, and if we have a quiz, I'm going to give you all nice numbers, so you don't need to use your calculator.
Mr. Park,
Yeah.
can you just put negative 52?
Yeah. See, look, somebody's thinking. Did you guys understand Galaccio? He said, can't you just put negative 53.1 degrees here because just go that much clockwise instead of going counterclockwise? Yeah. You're right, you can. Okay, next problem is 23. Write each complex number in rectangular form. See, now the way the book writes it, the book is not doing it the good way. The book is doing it the baby way. Now the way I'm going to give it to you on the quiz or test, it's going to be like this. I forgot the problem. Just walking from there to there. 2 kiss 120. 2 kiss 120 degrees. They want you to change this into standard form. Okay, this is the way I'm going to give it to you. And then, what is kiss an abbreviation for? Cosine theta plus I sine theta. That's the way the book gave it to you. But that's not the way I'm going to give it to you.
We're going to give it to us.
Like that. Were you here 30 seconds ago?
I understand what you're saying.
I'm saying this is the way the book wrote it. I'm not going to write it. I'm going to write it like I'm going to give the abbreviation because you guys got to get used to that. Right? You guys signed up for pre-calculus next year.
Yes.
Okay. Now, all you got to know is your trig values. What is the cosine of 120 degrees? Oh boy, here's the... Let me draw the unit circle.
It's wait.
120 degrees is right there. What is the x coordinate of that point? Look, you make the triangle. Look, when the short one is a half, the big one is √3 over 2, like we always did in abundant. So negative half. We gotta go to the left. To the left, to the left. And then what is the sine of 120 degrees? Root 3 over 2, and you always put the I on the second one, the side one. And then all you have to do now is distributize the 2, and you get, oh gosh,
One.
negative 1 plus root 3I. See, that's the kind you can get on the quiz. No need to calculate. I guess we're having a quiz then.
No.
Why?
That's a quiz.
A quiz, look, I'm gonna give you one practice quiz too. You know what, I came to school this morning, you know what I did all morning? Make the practice test. I'm just a slave.
You made it?
Okay, next problem, 27. 27, 3 kiss pi, 3 pi over 2. 3 kiss 3 pi over 2. Write this in standard form. Well, what is kiss an abbreviation for? Cosine theta plus I sine theta. And then you just gotta know your trig values. Okay, where is 3 pi over 2? That's right here. So come on, that's the 0.0 negative 1, right? So what is cosine of 3 pi over 2?
0.
0. Sine of 3 pi over 2 is negative 1. And then you put the I with always with the second one. And now distributize the 3. 0 minus 3I. Now if you wrote your answer like that on the test, they give you full credit. But come on. Negative 3I, right? Okay, just leave it on like this. You finished the quiz that fast?
No, not the other quiz.
Wait, you only had 10 minutes for the quiz?
No, yeah, I finished it, but it was crowding my test.
Whatever, Daddy. Okay, so is that it?
Yeah.
So what about 11 through 21? You guys could do those?
Let's just do all on this part.
No, I'm not gonna do all.
Can you choose a special one then?
Okay,
13.
okay, the kind I would give you, okay, let's do 13 then. Root 3 minus I. How come I gotta ask the questions?
I just said 13.
Root 3 minus I. So, again, it's like this problem. If you want to go from standard form to polar form, don't use the formulas. Draw a picture like I taught you. So here's the real and the imaginary axis. If I go root 3 to the right, woo! And I go 1 down, woo! How far from Oregon am I?
2.
Thank you. How come you guys take so long? The hypotenuse is always double the short leg. So whatever the short leg is, just double it. 2. So we're gonna change this to r kiss theta. So we know r is 2 already, right? That's 2. No, what's that angle there? Well, that's a 30, 60, 90 triangle. So, Mr. Park, I always get confused. I don't know if it's the 30 or the 60. Well, if it's the small one, it's 30, right? So you want to write, so if this angle is 30, what's the angle going all the way around like that? 330 degrees. Or you want to just go negative 30 degrees? I don't care, either one. I'll pick either. They're both correct, that's why. See? Draw the picture. It's so easy. So last night's homework, wasn't it like really easy?
Yeah, it's a lot.
Yeah. Okay, but now we're going to start learning some theorems. And it's not going to be that easy. Well, it kind of is until you get to the fourth one. Okay, I'm going to erase. Okay, so what do you got to know for tonight's homework? Basically, you got 3 theorems we're going to use. Now, again, why are we even learning this? Just so teachers have jobs? No, to analyze alternating current. But then when you do that, you want to use theorems we're going to learn today. Okay, first theorem. If, let's say you have 2 complex numbers. Z1 is equal to R1 kiss theta 1. See, it's already in polar form already. And Z2 is equal to R2 kiss theta 2. Then, part A, Z1 times Z2 is equal to R1 times R2 kiss theta 1 plus theta 2.
Wait, does this actually include graphing or this is?
No, this is no graphic, this is the applications of polar coordinates. Okay, so what does that mean, Mr. Park? Well, when you're multiplying two complex numbers, you simply multiply the r's and add the thetas. That's it. And then part B of that theorem is, if you want to divide complex numbers, you divide the r's, and what do you think you can do with the angles? You subtract the angle. Okay, do I have to give you an example?
Yes.
Okay, I will. Let's say, what if I ask you to multiply this out? 3 kiss 30 degrees, multiply that by 4 kiss 60 degrees. Well, according to this theorem here, when you're multiplying, what do you do with the r's? You multiply them. And what do you do with the angles?
Add them.
You add them. Finished. Because think about it. You know when you first learned complex numbers? Okay, what if somebody told you, multiply 2 plus 3i times 4 minus 5i? Just like on the SAT. How do you multiply complex numbers?
Add them.
You got a FOIL, right? So here, let me just show you. If you FOIL 8 minus 10i inside plus 12i, and then last minus 15i squared. But what is I squared again? Remember?
-1.
I squared is -1, so this is actually plus 15. So your final answer is going to be 23 plus 2i. Look how long it took you. Look at when you multiply the complex numbers like this. You just multiply the r's, add the angles, finish. It's way faster. That's why polar form is good. That's why we learn it. It's way faster. And then dividing is a whole nother animal. Like what if you had 15 kiss 120 degrees divided by 5 kiss 90 degrees? What would your answer be? What do you do with the r's? Look at this second theorem. What do you do with the r's?
Divide them by
You divide them,
Then you subtract them.
and what do you do with the two angles?
Subtract them.
You subtract them. What's 120 minus 90?
30.
30. Finished. That's it. It's that simple. Look, what if you have, okay, let's go back to Algebra 2. What if you have to divide this? 1 plus 2i divided by 2 minus 3i.
That's it.
How do you divide complex numbers? You remember? Did you guys go SAT prep? You gotta notice on the SAT, the new SAT has the imaginary numbers. How do you simplify something like this? You have to multiply top and bottom by the conjugate of the denominator. What's the conjugate of 2 minus 3i? 2 plus 3i, 2 plus 3i. And then both the top and the bottom, you gotta FOIL. But look how fast this was. All you gotta do, divide the r's, subtract the angles, finish. That's why we study polar coordinates, because it makes complex numbers easy. Okay, you guys can do that, right? Now, in your homework tonight, though, they might ask you to write the answer in standard form, though. Let me check your homework. Oh no! It says leave the answer in polar form, so you don't even have to change it back. You know, this is it. Just leave it. That makes it so much easier, because what if you had to change this back into standard form? Then you got to do this. What does KISS stand for? Cosine theta plus I sine theta. Yeah. And then you just got to know your trig values. What is cosine 30 degrees? Root 3 over 2. Sine of 30 degrees is a half with the I there. Distributize the 3. 3 root 3 over 2 plus 3 over 2i. That's your answer. But no, tonight you just leave your answer like that. Child's play. Okay, now, third theorem. So this is like first and second, but they're kind of combined into one. I need chalk. Now this theorem is a really powerful theorem. This is going to blow your mind. What if I give you a complex number like this? 1 plus 2i raised to the 8th power. How long would that take you?
Long time.
Fast, okay, here.
Oh wait, no, we learned how to do this in Mr. Bosch's class.
Okay, how?
Um,
Okay, some of you would have even trouble just raising it to the second power, right? How do you raise something to the 8th power? Oh, multiplied by itself 8 times. How long is that gonna take you?
An hour. An hour.
No, it's not. It shouldn't. Okay, it will take a long time though, right? Okay? But now we're gonna learn a theorem. This is called de Moivre's theorem. Named after the mathematician Abraham de Moivre. Obviously a French mathematician. De Moivre proved that if you have a complex number in polar form, so here, maybe I should write it like this. Then, if you want to raise it to a power, all you have to do is raise the r to the power, and you multiply the angle times the power. Okay, example. What if what if I just give you the problem like this? What is 2 kiss 30 degrees raised to the 6th power? And again, 1 plus 2y. What if I ask you to raise that to the 6th power? Like that, how long would that take you? Some of you would take all day. I don't know, right? But now, how do you raise a complex number to the 6th power if it's in polar form? Well, you simply raise the 2 to the power. What is 2 to the 6th power? Here, I'll just write it like this. And then you multiply the angle times the power, so that's 180 degrees. So all you have to do now is, what is 2 to the 6th? 64. So 64 kiss 180 degrees, boom, finished. You can do the problem in like 1 second.
Sorry.
God damn.
Okay, let's do another one. What is 3 kiss pi over 4 to the 8th power? So what does de Moivre's theorem say? 3 to the 8th. And what do I do with the angle and the power?
Multiply.
You multiply them. Come on, you cannot multiply 2 things together. 2 pi. Thank you. It took kind of a long time for that. So the hardest part for you guys is, what is 3 to the 8th power? Come on, look. If 64. Okay. If you don't know anything, 3 to the 8th power is 3 times itself 8 times, right? But look, that's 9 times 9 times 9 times 9. But everybody knows 9 times 9 is 81, right? So basically, isn't that just 81 squared? And come on, everybody can do this, right? 1, 8, 8, 64. So 1, 6 carry. So 6, 5, 6, 1, kiss 2 pi. See how powerful this theorem is? Because otherwise, without this theorem, here, do that. Go into a room and do that. And what if you had to raise it to the 100th power? Then what?
Just go home, cook rice.
No. In fact, you know what? On the test, I might, I just thought of it now. I made the practice test, I can still change it. Here's a problem I think I'm going to put on the test. Let's see if you guys can get it. Tell me if it's too difficult. Root 3 over 2 plus 1/2 I raised to the 100th power. No. You guys are class of 2017, most of you. 2017. Yeah. Or shall we just do 100? Is that good enough? Can you just make it first power, Mr. Park? No, I'm not going to make it first power. Okay, let's just do 100. Look, I'm trying to help you. We don't want help, Mr. Park. Okay, how do you raise this to the 100th power? Mr. Park, I couldn't even do it to the 2nd power. So what we do is we change this to polar form, because if it's in polar form, then I can use this theorem over here. Okay, let's see if we can do it. This is last night's homework. How do you change from rectangular to polar? What did I teach you? You draw a picture. If I go root 3 over 2 to the right and 1/2 up, How far from Oregon am I? Again, people, it's a 30, 60, 90 triangle. A hypotenuse is always double the short leg. 1. See, look, if that's a short, just double it. Okay, 1. And what angle is that?
30.
30 degrees, or pi over 6. No, you want to do degrees or radians? I'll leave it to you.
Degrees.
You sure?
Yes.
Okay, you want to go? Okay, 30 degrees then. Okay, now, how do you raise this to the 100th power? We use De Moivre's theorem. What is 1 to the 100th power? 1. See, that's way good. And then you got to multiply 100 times 30.
30,000.
No, please, 3,000.
3,000.
3,000 degrees. There you go. Okay, but then, see, 3,000 degrees is too big. We gotta, how do I get the angle smaller? Remember? When you work with trig functions, when you have a big angle bigger than 360, you keep subtracting multiples of 360, right? Remember? Okay, what would be a good multiple of 360 to subtract from that? What? 2400?
8.
What?
360.
Okay, see, I tell you what, that's why, to me, it's easier to, you see, because some of you are struggling, yeah? What you gonna do, just keep subtracting 360. Okay, so 3,000 minus 360 is 2,640. Subtract another 360.
Just
And you just can keep subtracting 360 till you get an angle you can work with.
360 times 8 is 2,800.
See, you guys are doing anything to avoid radians, yeah?
2,800.
Okay, so what are you saying? 360 times 8 is 0, 8, carry the 4, 2880. Subtract that from that. Mr. Mark, I can't do it in my head because I gotta borrow. 120, I heard somebody whisper it there. Okay, so if you reduce this angle down, you will get 120.
Okay.
Okay? And then, change it back. What does KISS stand for again? Cosine theta plus I sine theta. Now you gotta know your trig values. Uh-oh. Okay, let me draw the unit circle. 120 is over there. What? Negative half. And then sine plus root 3 over 2i. Distribute times the 1. So your final answer is negative half plus root 3 over 2i. Bam! Is that too hard for a test question? What? I can do this with my left hand.
What if we did it in radians instead?
Okay, what if you did it in radians, then you would go pi over 6. What is pi over 6 times 100? And don't say 100 pi over 6. 50 pi over 3, right? You reduce it. Yo, Mr. Burke, how are we going to subtract multiples of 2 pi? But how did I teach you to do this way back in the 3rd quarter? Change this to a mixed number. What is 50 over 3? 16 and 2/3 pi. So 16 and 2/3 pi. What is a good multiple of 2 pi to subtract from that? 16 pi, right? And you get 2 pi over 3, which of course is the same thing as 120 degrees. To me that was easier, but whatever! You can do degrees or radians, it doesn't matter. It's going to come out the same. Right? It's just like eating oatmeal or cream of wheat. It come out the same, right? I don't know. Okay, so, I don't know, should I put that on the test?
No.
Why not?
Bonus.
That's not a bonus, I just showed you how to do it. Okay, we'll just see, I don't know, because the test is kind of long already, maybe I should just leave that part simple, yeah?
Yes, please.
Who said that?
Wow.
Okay. And then the last theorem, this is the last theorem. This is called the complex roots theorem.
What about the remainder theorem?
No, we learned that already in Algebra 2. The complex roots theorem, okay, this is the hardest one, okay? If you have to solve an equation, z to the n is equal to r KISS theta, and again, see how it's in polar form? Now, before we even start this theorem, what if I were to ask you, z cubed is equal to 8? Okay? Z just represents a complex number, so normally we don't say x cubed equals 8. If you know it's a complex number, you just say z, but it's the same thing. How many answers are there going to be?
3.
Very good. How do you know?
Because the powers.
Yeah, when you have a polynomial equation of degree n, you will have exactly n solutions. Remember that from Algebra 2? What theorem is that called? If you have a polynomial equation of degree n, you will have exactly n solutions.
Powers theorem.
Huh?
N theorem.
The what? The n theorem? It's called the fundamental theorem of algebra. And you guys were in my class, I taught you this. Remember, and then I taught you synthetic division, how to find those solutions? Even though the other classes never learned that. Lee? You're just nodding your head. Okay, anyway, so if you have to solve this equation, you're going to have 3 answers. If it's 4th power, we're going to have 4 answers. If it's 5th power, we get 5 answers, okay? So, if you have z to the n equals r kiss theta, I'm going to have n answers. How do I get the n answers? Here you go. You ready? Z is equal to the nth root of r kiss theta plus 2k pi over n, where k is equal to 0, 1, 2, dot, 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 n minus 1.
Holy shit.
That has three.
Holy what?
Wait, is the kiss not in the root r or the n root r?
Say that again?
It's just n root r and not n.
That's the nth root of r,
Okay.
and then kiss is
It's on the
the...
outside.
What does this mean, Monsieur Park?
Is that an N or an R?
Where
Under the.
n, this is an n.
Is that it? What's
Okay, I told you this theorem was going to be difficult for you. Why don't I give you an example?
just right next to the z? What is that? Is that a h?
Equals
No, right next to that.
And.
to the n. Why is there, I never said the word h in my life. I mean here. H. Did I ever say the letter H? Okay, let's just do a problem. In fact, let's do the one I just did. No, let's do it, make it a little tougher.
No.
Z cubed equals 8i. Just to make it a little tougher. Okay?
Yeah.
Okay? First of all, how many answers am I going to have?
Trace.
3. There's going to be 3 answers. So in other words, we want to find what number cubed will give you 8i. There's 3 answers, okay? How do you find these 3 answers? So the first thing you got to do is you got to change this into polar form. See, you got to put it in polar form. Now, in tonight's homework, they might give it to you in polar form, do they? Yeah, no, no, a couple of them they don't. Okay, so there, take that. How do you change this into polar form? What's the fastest way? Draw the picture now. Mr. Park, that's only 8i. Yeah, but that's like 0 plus 8i. Maybe you should put the 0 there to help you out, okay? So, draw the picture. If I plot the point 0, 8, right? That's up here. If this is the point 0, 8, how far from Oregon am I? 8. And what's that angle right there? 90 degrees. Now, you want to do degrees or radians?
Radius.
No, let's do degrees then. Whatever you say, I'm going to do the opposite. Unless I don't. Okay, now that you got it in polar form, now we apply the theorem. So let's identify all the letters that you need to know. This is n, this is r, this is theta. All you gotta do is plug and chug into that formula. That's your favorite, right? Just plug and chug. Okay, let's derive it then. So z is equal to, what does it say, the complex root theorem? The nth root of r. So if n is 3, what? The cube root of 8. Kiss, what does the theorem say?
90 degrees.
Theta, what is theta here?
90 degrees.
90 degrees plus 2k pi. However, if you're doing degrees, instead of 2k pi, see if you're doing radians, you do 2k pi, but if you're doing degrees, what is this?
2k.
Well, we know 2 pi is how many degrees?
180.
No.
360.
360. So if you're doing degrees, then it's 360k. Okay? So 360k over n, what is n in our problem? 3, where k is equal to 0, 1, and 2. How come I stopped at 2, Mr. Park? Why did I stop at 2?
Only three answers.
Because look, yeah, there's 3 answers, and on top of that, if n is 3, then what is 3 minus 1? 2. So this tells you where to stop. And then you guys said it. To get your 3 answers, you're going to be plugging in these 3 numbers in for k. That's how you get the 3 answers. Okay, here we go. What is the cube root of 8? 2. See, that's why Pig made it like that, so it comes out nice. I don't know if your book is good enough. Okay, let's see if we can do this in our head. If I plug in 0 for k, can we do this in our head? What is 90 plus 0 divided by 3? Hey, we got the, so that's one answer.
2k.
That's one answer. The second answer is going to be 2 kiss, and then now you plug in 1 for k. Let's see if we can do this. What is 90 plus 360? 450 divided by 3. 150. And then finally, plug in 2 for k. 90 plus, what's 360 times 2? 720 plus 90 is 810. What is 810 degrees divided by 3? 27. Two. What? That's just arithmetic. You're easily impressed, here. 2 times 3 is 6. Oh, bro. There you go. Those are your 3 answers. Now, I want you to notice something. If I were to graph these 3 answers, look, if I were to graph that, look. Okay, here. Let's say you have a circle of radius 2. How do you graph this? Remember, a complex number is a vector, right? You make it 2 units long, making a 30-degree angle. Kind of looks like that. How do you graph the second one? Like that. And then the third one, like that. I'm just graphing it just so that you can see something. What do you notice about the 3 answers?
The angles we know.
They're equally spaced apart. Now, is that always going to be the case? Anytime you use this theorem, are however many answers you have, are they always going to be equally spaced apart?
Yep.
Yes. So that means that can help you. So that means, because some of you are struggling plugging in 1 and 2, yeah? Admit it, you were struggling. So once you get the first answer, you really don't need to use the formula anymore because you know they're going to be equally spaced apart. So if there's going to be 3 answers, what is 360 divided by 3?
120.
120. That means they're always going to be all 120 degrees apart. So once you get the first answer, the second answer just add 120. The third answer just add another 120.
So really, you just
survive
have to
how many
over-
solutions there are.
Yeah, exactly. So let's just do one more and we're done today. What if you have z to the 4th is equal to 16, I'll make it shorter for you. 16 kiss, I'm trying to think of a number that's going to be 200, let's do radians this time. 2 pi over 3. No! 4 pi over 3.
What if you had it to like 11, or it doesn't divide nicely by
Then you just put the ugliness, right? You can have but don't worry, I'm not going to make, I don't like ugliness. Okay, so, using the complex roots theorem, how many answers are there going to be first before we start? 4. It's 4 answers. So z is equal to, remember, this is n, this is r, this is theta. Just plug it into that formula. The 4th root of 16, kiss, 4 pi over 3 plus 2k pi all over n. What is n in our
Four.
problem? 4, where k is equal to 0, 1, 2, 3. How come we stopped at 3? Because n minus 1 is 3. Okay, so the first answer is going to be, you plug in 0. Everybody can plug in 0, right? First of all, what is the 4th root of 16? 2. See how I made that? Come on, nice 4th root. Kiss. Okay, if I plug in 0 for k, this is 0. What is 4 pi over 3 divided by 4?
Pi over 3.
3 pi over 3. That's the first answer. Now, there's going to be 4 answers all equally spaced apart, right? So what is 360 divided by 4? 90. So all the answers are 90 degrees apart. Or if you're using radians, what is 90 degrees? Oh boy.
Pi over
Pi over 2. So the next answer, see, you don't even have to plug in 1, 2, and 3 anymore. I mean, if you want to, you can. Just keep adding 90 degrees, or pi over 2. Add pi over 2 to this.
2 pi over 6. Right?
Which is,
Pi.
how come we cannot, okay, you know what?
2 pi over
Maybe you guys
3.
should change it to degrees and just keep
Wait,
adding 90 there.
wait, I'm so confused.
Just keep adding 90 degrees.
How over,
Yeah.
how over 3 plus pi over 2?
Okay, pi over 3 plus pi over 2.
Why are you so hard right
Make the
now?
least common denominator.
6.
Thank you, 5 pi over 6.
Man, I'm dumb.
Okay, the next answer, add another pi over 2. Okay, I'll give you a hint. Pi over 2 is 3 pi over 6,
8 pi over 6.
which can be reduced.
4 pi over 3.
Thank you. See, you can do it. And then the last answer, add another pi over 2 to it. Uh-oh. Make a here.
11 pi over.
There you go. Thank you. 11 pi over 6. Mr. Park, can I just change, like at the start, couldn't I have just changed that to, how many degrees is that? Oh gosh.
1.
No. By now, you should know that, well, you should know that that's just 240 degrees, right? But everybody, pi over 3 is 60, right? So it's 60 times 4, 240, right? Mr. Park, couldn't I have just changed this to 240 and then just work with degrees? Yeah, I don't care. Degrees or radians, I'll take either. So anyway, the point is, if you know they're equally spaced apart, then after you get the first answer, then just keep adding to that. You know what I mean? Kind of like a rose curve, kind of, yeah.
If we did it in degrees, and then we kept on adding like 90, and then it got over 360, do you want us to?
Then no,
we just
no,
keep
it will never go over 360. It will never. See, if you did it in degrees, okay, this is 240, okay, put 240 here. What's 240 divided by 4?
Oh.
It's 60, right? And then you're just gonna keep adding 90, right? So add 90 to 60, what do you get? Add another 90. 240, add another 90. 330. See, it will never go past 360. Well, if you're doing it correctly, it will never go past 360.
So it's never goes past 360.
No, you.
Okay, so tonight's homework, all you gotta do is just follow the examples I did, you should be fine. All right. So this class, and what time did we start? 40, so this class could end at, you got 20 minutes, no, 50.
It'll be something out.
Okay, you guys got 20 minutes remaining. Here's the thing, maybe I should do my homework. Why am I looking over there?
The book's over
This
there.
is
No, who's Jeff? You mean Chuck? Chuck's over here. All right, we're done. Oh, that lecture was kind of long.